All right, so just as we indicated that we are going to look at some associated electrical components, and we said that we are going to look at the four major one. Now, in electronics, or that is the basic aspect of electronics, because we are dealing with design of circuits and trying to control the behavior and movement of electrons in a semiconductor, a conductor or vacuum, we have to look at some of these electrical components. So the first electrical component we are going to look at is the resistor. Resistor. So just as the name implies, so this in terms of symbol, a resistor can be of this form. It can be of this form, it can be of this form, it can be of this form. So these are the color code resistors. So color code resistors. So based on the color, you can calculate the resistance this resistor is going to what provide. This is also a symbol for a resistor when you are drawing a circuit diagram. Now, what then is a resistor? So a resistor is a passive device. So a resistor is a passive device. What does it do in an electrical circuit? So what resistor does is that it opposes the flow of current. So it's a passive device that opposes the flow of current, oppose the flow of electrical current or electric current. So that's what resistor simply does. So when let's say we have a conductor and current is flowing through the conductor, what the resistor does is to oppose the flow. So assuming, let's say we have 20 ampere flowing through the conductor, what the resistor will do is that it will oppose it. So allowing 20 amperes to flow through it, it will maybe allow, let's say, 5 or let's say 15 amperes only. So in this case, it has opposed a portion of the current that is flowing. Now, it's very important because when we look at in terms of protecting electrical gadgets, resistors play a key role in that. Now, resistor, just as we said, is an electronic device, opposes flow of current. What property allows it to oppose the flow of current? Is its resistivity. Its resistivity. So that is the property that allows it to oppose current. Now, because the resistor has high resistivity, so it has high resistivity. Because of that property, it is able to oppose the flow of current. Now, every material has this property called resistivity. Now, for resistors, its resistivity is very high, and that enables it to perform its function as what as a resistor. So even the conductors that allows current to flow through it, the conductors. So let's say copper, for instance, which is a popular conductor. Let's say aluminum, for instance, which are popular conductors. Although they are conductors and they allow electric current to flow through them, they have a form of resistivity, or they have a level of resistivity, and that resistivity is low. And so the resistance these things will provide, the resistance they will provide will also be what? Low. So their resistivity is low, and so the resistance that they will provide is also what? Low. So in basic term, that is what a resistor is all about. Now let's look at something. Let's look at formula for finding the resistance of a device. So the resistance that a material will provide is equal to its resistivity, the length of the material divided by its cross-sectional area. So just as I indicated, that every material has a form of resistivity, and that resistivity is the property that will contribute to the resistance. Are you okay? And so if I want to determine the resistance any material at all will provide, is based on its resistivity. So this symbol, the resistivity of the material, is based on the length of the material, and that is the L. So the length is the L, and it's what cross sectional area. Cross sectional area. Do you get it? Cross sectional area. So just as I said here, that assuming a 20 ohm current is flowing through a resistor which has high resistance, it will allow, let's say, 15 ampere to flow. So where did the 5 ampere of current go through? In most cases, the resistor converts the current that it's resisting to what we call heat. It converts it to heat because remember, energy cannot be created nor destroyed. So this energy of current will be converted into heat, and it will be dissipated by the resistor. So in most cases, you have a gadget and you realize that, for instance, you are charging your mobile phone, you realize that your charger has become very hot. It's because the resistors within it are resisting current and dissipating that resisted current in the form of what? Heat. And we have two types. We have types of resistors. So let's look at the types of resistors. Types of resistors. Types of resistors. So one, you can have the variable resistor. So the variable resistor can have two, the potentiometer, potentiometer. Then three, you can have the rheostat. So the rheostat, it can be regulated. It's a form of resistor that can be regulated. And this is the symbol for resistor. So if not anything, you should know what a resistor is, what it does in an electrical circuit, what property of the resistor enables it to resist the flow of current. And you should also bear in mind that every material in this world has a certain level of resistivity. If you have a low resistivity, then it means that you can allow current to flow. If you have a high resistivity, then it means that you are going to oppose what current, or you are going to resist current. So that is it for resistor. So just as we said that the resistance of any material is equal to the resistivity multiplying the length over what? The cross-sectional area. So we have two questions here that we are going to try our hands on using this formula. Using this formula. Now, they said that a copper wire with resistance. So the resistance of the copper wire is 12.8 milliohms, has a cross-sectional area, that is the area, which is 1.15 by 10 to the power negative 5 meter squared. That is very, very, very small. Then they are asking us to find the length. We should find the length if the resistivity of the copper wire is equal to 1.7 by 10 to the power negative 8 ohm meter. So this is the question that we have. Just as I indicated earlier on, that every material has a form of resistivity. Do you get it? And by that resistivity, we can find the resistance that the material will produce. So using this formula, so with a given formula, R, resistance is equal to resistivity times length over cross-sectional area. Now the question is asking us to find L, so we have to make L the subject. So it's going to be equal to resistance times the cross-sectional area all over resistivity, and that is going to be equal to the length. So what is the resistance in the first question? That is 12.8 milli. That is by 10 to the power negative 3, right? Then times the cross-sectional area, which is 1.15 by 10 to the power negative 5, all over the resistivity, which is 1.7 by 10 to the power negative what? 8. And this is equal to the length. So by computation, we can get our answer. So when you use your calculator, you're going to get 8.86 meters to be your length, right? Then we'll look at the second question. Let's look at the second question. All right, so that was the first question. Now let's look at the second question. The second question, the second question, question two, let's look at the solution for it. So we have a copper wire with resistance. So the resistance for the copper wire is 22 milliohms, has a length of 6.2 meters. Then the resistivity of this copper wire is 1.7 by 10 to the power negative 8 ohms meter. Now we are asked to find the cross-sectional area. So if you read it carefully, so in solving questions like this, make sure you write the parameters down. So a copper wire with a resistance of 22 milliohms has length of 6.2 meters. Find the cross-sectional area. Use 1.7 by 10 to the power negative 8 ohms meter for the resistivity of copper, and give your answer in scientific notation to 1 decimal place. So that's what we have been asked. Now we know from the formula that resistance is equal to resistivity multiplying cross length over cross-sectional area. If I want to make cross-sectional area the subject, is going to be resistivity multiplying the length divided by the resistance. So it means that the cross-sectional area is going to be 1.7 by 10 to the power negative 8 by the length, which is 6.2, all over the resistance. That is 22 by 10 to the power negative 3. So we are going to get 4.79. Let me erase this thing so that you can see it clearly. So we are going to get 4.79 by 10 to the power negative 6 meter squared. So we can see that the area is equal to 4.8 because it says 1 decimal place. 4.8 by 10 to the power negative 6 meter squared. So there's the scientific notation. You can also leave your answer as 4.8 millimeter squared. And that's it. Thank you for joining us.